Continuing, Chapter 6, Section 2. Now we're at the section on determining normality. All right. So here we're going to take a peek at example, I don't know, whatever the next one is. No, that's a cop-out. I do know. Here it is. It is example 6-11 on page 335. So we'll take a look at what it says here. Technology inventories. Okay, so that's the theme. Survey of 18 high-tech firms showed the number of days inventory they had on hand. All right, so we have a data set given there. Determine if the data are approximately normally distributed. So here we're basically asking the question, is it normal? Is it normally distributed? Determining normality. All right, so just silly remark. Whenever I have to ask myself if something is normal, is this normal? The answer is usually no. Anyhow, okay, so it reads us off the data. I've gone ahead and just typed it into Google Sheet here, so they are listed down here. Disregard this up here. Let's maybe on the wrong keyboard. Anyhow, so the N and X and P, don't look at that. Here I've listed the data going down. So the data that they give us in this example are 5, 29, 34, et cetera, all the way up to 158. So it's kind of nice they've gone ahead and given it to us here all in order. All right, and so basically what it says to do is to determine if this data are normally distributed. All right, so what I'm going to do first is use the nice features of what's it called here, Sheets, or any kind of spreadsheet program, and just go ahead and highlight all of that data. I've already set it up to use to give us a chart here. So I've gone to Insert and Chart, and then over here in the where'd it go? Over in the chart information, in the setup here, you can see I've chosen the chart type and histogram chart. So it's kind of nice. We know how to construct a histogram, but it's very nice that this one will actually do it for us. Here, let me see what else could we do here? Let's see, the histogram chart. I can kind of try to customize it. It's interesting. It gives us an option not for the number of buckets. Remember, that's the number of classes, right? It conveniently enough calls them buckets. It just says we're auto-generating them. It looks like it's given us 5 classes. And so it is doing that calculation that we did, taking the max value minus the min value and divided by 5, and then bumping that up. So notice it's covering all of our data set here. But it's just generating that automatically. Now we can go in and set our bucket size to whatever we want, but here I wouldn't recommend that because that won't give us what we want. What we would like to do is be able to adjust how many buckets we have, but for our data we can't have just our buckets be 1, because that would be, well, I don't know. That would kind of look like a box and whiskers chart a little bit. Here, if the buckets are 50, they kind of overlap too, or there's too few of them. If there's 25, well, oh well. But noticing our proper histogram, it generates, however many classes it feels is appropriate. Looks like, well, looks kind of like a bell-shaped curve. So in terms of answering the question, is this data normally distributed? I would say, yeah, the histogram for it appears to be a bell shaped, and so it looks like it's normally distributed. Is it skewed to the right or is it skewed to the left? I mean, is this tail of the graph as even as this tail of the graph? As you can see, when we adjusted the bucket size a little bit and put it kind of like that, you can see it's kind of got these gaps, maybe, or a gap over here. It's got a few holes in it, so some of the buckets aren't getting filled up. Look at that. So anyhow, does that indicate that our data is skewed one way or another to the right or to the left? So there is a test for skew. It is what we call here. Let's see. It is Pearson's coefficient, right? And we will do this by multiplying 3 times our mean chi-bar, right, minus the median. And unfortunately, we don't have a nice symbol for that, so I have to write the whole word, okay? And then divided by the sample standard deviation. So that is S, not sigma, just S. All right, so that is how we will calculate Pearson's coefficient. And for this one, notice I've gone ahead and actually done that on the spreadsheet as well. All right, so notice here that calculation uses the mean for the sample. So here I've made it do the average for me, right? Over here, well, it was kind of nice. I guess if it didn't give us the data in order, we could just make the spreadsheet program sort it for us. There's probably a way to do that. But at any rate, I can simply call the function median, and notice I've put that whole range of data for the input for that function, and so that calculates the median. Notice it is in order, so like I was saying, here we can either select the exact middle value if it's an odd numbered data set, or the middle 2 values, and then we could simply average those together, and either way we would get the median there. And then here, as you can see from the formula bar here, it's a little bit hard to read. Maybe just pull in a little bit on that. There you go. You can see I've set that equal to 3 times A20. So that's, remember, this was chi-bar right here, minus C9. So right there, that's where I wrote the median. So it stores those values right there. And then we didn't calculate the standard deviation for this data set yet, but that would be the sample standard deviation. So this is abbreviated STDEV.S to indicate that it's the sample standard deviation of that same data set. And notice here, that's gone ahead and calculated that value as 0.1483. So that indicates what direction it is skewed in. And here, the value is very close to 0. It's ever so slightly positive, right? Okay, I mean, it's a positive number. So that means that this data set is not very skewed. If it were, it's just like a slight skew to the right because this coefficient is positive. This coefficient, if it were greater than +1, that would indicate that it was strongly skewed to the right, okay? If it were negative and greater than 1, sorry, I'm saying that wrong. If it were less than or equal to -1, so a big negative number, that would mean that it was strongly skewed to the left. But here, the value is very close to 0, so that indicates that it is not very skewed. It is roughly centered around the middle. The difference between the median and the mean is not very much, and that's what we are doing in this calculation. It is primarily, that's the main factor that we're looking at. We're looking at the mean minus the median there. So both of those, the fact that our histogram that we know how to do is roughly normally distributed, it looks like our data set is normally distributed, and we did a calculation that is close to zero. That indicates that this is roughly normally distributed. There's not a whole lot of data there, right? So that's one of the drawbacks here, but we can assume that it is roughly normally distributed, at least. All right, so we'll stop here for this example.